Assalamualaikum warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Good morning, ladies and gentlemen, distinguished speakers, respected guests, and honorable participants. It is with great pleasure for me, Danang Satriono, stand before you as the Master of Ceremony for the 10th International Conference of Engineering, Technology, and Industrial Application, or ICETIA, and also the 22nd Rekayasa Aplikasi Perancangan dan Industri, or RAPI 2023, together with my partner here, Alaya.
Today promises to be an intellectually stimulating journey, and I'm thrilled to guide you through our comprehensive agenda. Before the conference begins, I will explain the rundown for today's agenda. We will start with Tilawatil Quran by Muhammad Albi Al-Mahdi, continued by singing Indonesia Raya Anthem and Sang Surya. And after that, will be the official opening of the conference from Vice Dean of the Engineering Faculty, Mr. Muhammad Solikin, PhD. The Vice Dean will deliver the introductory remarks and officially declare the conference underway. This segment will take from 7:45 to 8 a.m.
And after the opening, we will continue to the first panel session. We are honored to have two distinguished speakers today. The first speakers will be Associate Professor Rois Fatoni, PhD, and the second speakers will be Associate Professor Carol C. Kilin, and the moderator will be Associate Professor Purwanti Sri Pudyastuti. The first panel session scheduled from 8 to 10.
After an intellectually enriching morning, we will take a short break for a coffee from 10 to 10:15. This is an excellent opportunity for networking and informal discussions. The momentum continues in the mid-morning with parallel session 1, scheduled from 10:15 to 11:45. This session is designed to provide a platform in-depth discussion on various topics, offering participants a chance to explore diverse perspectives within smaller groups.
Following parallel session 1, we will break for lunch from 11:45 to 13. And the afternoon sessions will be parallel session 2 from 13 to 14:45. Similar to the morning parallel session, this segment will offer participants to engage in fruitful discussion within smaller groups.
At 14:45, we will pause for a brief coffee break and prayer time, allowing participants to recharge and reflect in their own way. As we move into the final stretch of the conference, we are excited to present panel session 2 from 15:30 to 17:40. Our esteemed speakers for these sessions are Dr. Ridi Saluja and Dr. Puspita Ayu Permatasari. Dr. Saluja will share their insight from 15:30 to 16:15, and Dr. Permatasari will follow from 16:15 to 17. We will then conclude the day with a dedicated Q&A session from 17 to 17:30. Providing our final opportunity for participants to engage with our speakers.
I encourage each and every one of you to actively participate, ask questions, and take full advantage of the wealth of knowledge and expertise present here today. There will be an announcement for the best paper at the end of the conference, so please make sure to stay with us, until the last agenda.
So let's make this conference a memorable and intellectually rewarding experience. Thank you for your attention, and let the discussions begin with reciting Basmalah together. Bismillahirrahmanirrahim. So we will start today's agenda with Tilawatil Quran by Muhammad Al-Mahdi.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يا أيها الذين آمنوا إذا قيل لكم تفسحوا في المجالس إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير والله بما تعملون خبير صدق الله العلي العظيم. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Muhammad Albi Al-Mahdi, for the beautiful recite of the Holy Quran. The next agenda will be the official opening of the conference from Vice Dean of the Engineering Faculty, Mr. Muhammad Solikin, PhD.
Pardon. There will be singing Indonesia Raya before the opening speech. Okay. For the next agenda, we'll be singing Indonesia Raya and Sang Surya. For the audience, please kindly stand up.
The next agenda will be the official opening of the conference from Vice Dean of the Engineering Faculty, Mr. Muhammad Solikin, PhD. For Mr. Muhammad Solikin, PhD, please come to the stage.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. The Honorable Dean of Faculty Engineering Universitas Muhammadiyah Surakarta, the Honorable Committee of ICETIA and RAPI 2023, the honorable keynote speakers and invited speakers. In here stated that we have Professor Dr. Sami Ben Slama, Dr. Puspita Ayu Permatasari, and then we have Associate Professor Carol C. Kilin. We also have Dr. Ridis Saluja, Associate Professor Rois Fatoni, and Professor Lianake De Silva. And the honorable presenters, distinguished guests, ladies and gentlemen. Praise be to Allah, the Lord of the universe, who has been giving us blessing and mercies so we can attend this year conference. Let me, on behalf of Dean, Faculty of Engineering, and Committee of the conference, extend a very warm welcome to you all who attend this opening remark of our annual conference, both for you who attend this session offline and also online. This conference, what we call it as ICETIA, International Conference on Engineering, Technology and Industrial Application, and also RAPI, Rekayasa, Perancangan, dan Aplikasi Industri, is an annual conference hosted by Faculty of Engineering Universitas Muhammadiyah Surakarta. And this conference become part of ICET, the International Summit on Science, Technology and Humanity, also an annual conference from University Muhammadiyah Surakarta. The ICET itself includes 14 joint conferences and has been officially started by an opening ceremony on Tuesday, 5th of December 2023. This university, Universitas Muhammadiyah Surakarta, is the largest private university in Central Java, host of about 40,000 students. This university represents the contribution of Muhammadiyah organization in education, because Muhammadiyah organization has more about 170 higher education, and one of them is Universitas Muhammadiyah Surakarta. In addition, I need to mention that the Faculty of Engineering has 10 study programs, 11 actually, and this one include undergraduate and postgraduate programs. For this year, ICETIA and RAPI, this conference attract more than 100 presenters, and they are from Indonesia, UK, Australia, Japan, Thailand, Malaysia, Taiwan, Saudi Arabia, and Brunei Darussalam. So let me express my gratitude to all keynote speakers and presenters who support this event. This year conference has a special theme of synergizing Bengawan Solo conservation and environmentally friendly batik and textile industries towards a sustainable river basin. As we mentioned in the website of conference, Bengawan Solo becomes the longest river in Java Island. The upstream of Bengawan Solo lies in Sewu Mountains, around 77 kilometers from this place, and spanning about 370 miles. The river plays important role for farming, transportation, and fishing activities. However, the river faces some problems, such as water pollution and narrowing of the river bank. Therefore, conservation of Bengawan Solo River become important topic to be discussed. In addition, batik is United Nations UNESCO Intangible Cultural Heritage, and this type of clothes is origin from Solo as well. Therefore, discussing those topics in this conference will show our responsibility to our heritage. Distinguished guests, ladies and gentlemen, for all paper that has been accepted after review by our scientific committee, it will be published in Scopus Index proceeding. And also, it will be published in a journal. For RAPI article, it will be published in national proceeding. Therefore, in this occasion, I would like to thank to all scientific committee for your contribution to review all the articles. Moreover, this publication is ensure that all your academic product is well documented. Distinguished guests, ladies and gentlemen, the agenda of the conference is not only an academic sharing session that we conducted today, but also the participants have the opportunity to join a workshop on batik that will be conducted tomorrow. So please feel free to join the workshop. In this session, I would like to thank to all committee members of ICETIA and RAPI 2023 for your hard work and your contribution to make this conference successful. At last, thank you for your kind attention and enjoy this two-day conference session. By saying Bismillahirrahmanirrahim, officially the ICETIA and RAPI 2023, let's begin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Muhammad Solihin, PhD, for the introductory remarks and the official opening of this conference.
After the opening, we will have the first panel session. For the first keynote speaker will be Associate Professor Rais Fatoni, PhD, and the second speakers will be Associate Professor Carol C. Kilin, and the moderator will be Associate Professor Purwanti Sri Pudiastuti. And this is the curriculum vitae of Purwanti for the operator. Mrs. Purwanti, curriculum vitae. Okay, yeah. Without further ado, for Mrs. Purwanti Sri Pudiastuti, please come to the stage.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the ICETIA 2023 conference. We are excited to have you join us in this hybrid conference. And my name is Purwanti Sri Pudiastuti, and I will be the moderator for this first panel session. And as a moderator, I will be responsible for hosting this first panel today. And I'm glad to welcome our distinguished keynote speakers for this panel session, Associate Professor Rois Fatoni and Associate Professor Carol C. Kilin. And as moderator, I will be monitoring the time during this panel session. So we have 90 minutes for presentation by two keynote speakers, and then followed by 30 minutes discussion or question and answer. And for the online participant, we will have designated time to address the questions, but you may submit questions at any time during the session by writing your question in the Q&A text box. Okay, let's get started. As we know, the 17 SDGs accepted by all United Nations member states in 2015 cover a wide range of issues associated with socio-economic, environmental, and technological development. And the SDGs are applied for all countries around the world, not just those classified as developing or emerging countries. And for the SDG 4, it calls for equal access to tertiary education, including university, as part of promotion of opportunities for lifelong learning for all. So the universities play an important role in the SDGs, serving as a catalyst for the achievement of the entire set of goals through their roles in human formation, knowledge production, and innovation. And in the next 45 minutes, we'll be listening to the first keynote speakers who will deliver a presentation titled The Role of Muhammadiyah Engineering Higher Education in Achieving Sustainable Development Goals. The first keynote speaker received his bachelor's degree in chemical engineering from Universitas Gadjah Mada, Yogyakarta, and Master of Science in Chemical Process Design from University of Manchester, England, and he was awarded with PhD in Chemical Engineering from University Waterloo, Canada, and he has published more than 70 papers about refinery optimization, natural fiber composites, chemical product design, and tofu industry safety. And he is member of IOEM Society and Persatuan Insinyur Indonesia, and he is currently the Dean of Faculty of Engineering Universitas Muhammadiyah Surakarta. Now please welcome our first keynote speaker, Associate Professor Rois Fatoni. Pak Rois Fatoni, stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Innal hamdalillah nahmaduhu wa nasta'inuhu wa nastaghfiruh wa na'udzu billahi min sururi anfusina wa min sayyiati a'malina. May yahdihillahu fala mudhillalah wa may yudlilhu fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma salli ala Muhammad wa ala ali Muhammad kama shallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Amma ba'du. Ladies and gentlemen, distinguished guests and speakers, Assalamualaikum warahmatullahi wabarakatuh. Welcome to the 10 ICETIA. Yeah, but now I speak as keynote speaker, yeah, not as a dean, yeah. Okay, please, operator. When Pak Eko asked me, actually it's not ask me, insist to make me keynote speaker. I don't know what to say except yes, yeah. But during last 3-4 days, I become PSC, permanent head damage, yeah, because I don't know what to say, gitu, yeah. And then here I am, yeah. I will talk about the role of Muhammadiyah engineering higher education in achieving sustainable development goals. Yeah. Since last year's, the ICETIA seminar themes, we agreed to continuously take SDGs as a main theme in our ICETIA. Yeah. And also for this year's theme, Batik and Pengawan Solo, as explained very well by Dr. Solihin, we would like to become center of Batik and Pengawan Solo in Indonesia, the Faculty of Engineering. In today's talk, I would like to start with overview of Muhammadiyah, yeah. Muhammadiyah, Persyarikatan Muhammadiyah, Muhammadiyah organization, one of biggest Islamic reform movement in Indonesia and also in the world. And then I will continue to engineering higher education in Muhammadiyah universities in a brief. After that, I will review in short about Islam and SDGs, and then engineering education and SDGs, and then the challenge, yeah, the challenge for higher education, higher engineering education, especially Islamic higher engineering education, including Muhammadiyah, to address this issue, this SDGs issue. And then how Islamic values in UMS to be reconstructed to accommodate the issues of SDGs. And then I will sum up with some concluding remarks. Next, please. This is the overview of Muhammadiyah organization. In 2021, Robert Hefner made a statement that the most successful religious non-governmental organization in the world is Muhammadiyah. Yeah. Currently, Muhammadiyah manages more than 170 higher education, 457 hospitals and healthcares, and all community services in education and health services. Established in 1912 by Kiai Ahmad, the main activities of Muhammadiyah is to provide education and health services. Estimated this year, Muhammadiyah asset reached 400 trillion rupiah. Yeah, 400 trillion rupiah for the asset of Muhammadiyah organization. So that's why Robert Hefner, actually Dr. Robert Hefner promoted Muhammadiyah and Nahdlatul Ulama to receive Nobel Prize, yeah, but not happened yet. Okay, next please. Imagine we are living in Afghanistan, yeah, now, when Islam is not compatible with the modern world, yeah, everything comes from the West, Muslim there denied, rejected, yeah, and then that is more or less the same situation when Kiai Haji Ahmad Dahlan and his companion live in early 90s. Yeah. Everything that the Dutch colonials bring is not compatible with Islam. Muslim has Muslim has their own healthcare system. Muslim has their own education system. Yeah. People, they don't trust doctors, hospitals, because doctors, all of them Dutchmen, Christian, not Muslim, kafir. Okay. Also school, Muslim, they don't go to school. They go to pondok pesantren, and then come Kiai Haji Muhammad Dahlan, yeah, to reform this situation. After studying in Mecca for several years, he come to Indonesia and promote Muhammadiyah. This is not the correct way of doing the Islam religion. So this is one of quotes, yeah, that Kiai Haji Ahmad Dahlan give. If we are living in this year, this is very common. But imagine this quote, yeah, in 1912, yeah. Muhammadiyah pada masa sekarang ini berbeda dengan Muhammadiyah pada masa yang akan datang. Karena itu hendaklah warga muda-mudi Muhammadiyah terus menjalani dan menempuh pendidikan serta menuntut ilmu pengetahuan dan teknologi di mana dan kemana saja. Menjadilah dokter, sesudah itu kembali kepada Muhammadiyah. Jadilah master, insinyur dan profesional, lalu kembalilah kepada Muhammadiyah sudah itu. This saying comes from Ahmad Dahlan, the leader of religious organization. Ya. Ini nasihat ini keluar dari Kiai Haji Ahmad Dahlan, pemimpin organisasi keagamaan. Ya. Perintahnya itu adalah jadilah dokter, jadilah mister, jadilah insinyur. Yeah. His order to society is to young generations, become doctor, become engineer, become mister, become professional. Yeah. This come from top leader from religious organization. So this is very visionary. Ini adalah sangat visioner. Actually, we Indonesian people in much step to him, because without his movement, without his activities and his companion, probably today we are not compatible with the modern world, like what Muslim in Afghanistan doing right now. Also for the girls, yeah, imagine, yeah, in Muslim world, in the colonial era, Ahmad Dahlan give advice to young girls. One day, suatu saat Kiai Ahmad bertanya kepada anak-anak perempuan Muhammadiyah, apakah kamu tidak malu jika auratmu dilihat kaum lelaki? Anak-anak muda perempuan itu serentak menjawab bahwa mereka akan malu sekali jika hal itu terjadi. Kiai lalu berkata, jika kau malu, mengapa jika kau sakit lalu pergi ke dokter laki-laki, apalagi ketika hendak melahirkan anak. Jika kau memang benar-benar malu, hendaknya kau terus belajar dan jadilah dokter. Ini adalah nasihat seorang kiai pemimpin organisasi keagamaan. Perintahnya adalah jadilah dokter. This is very visioner. Ini sangat visioner. Next, please. Now for engineering higher education. Currently there are more than 170 universities managed by Muhammadiyah, and 75 of the universities has science or technology engineering faculty. 58 of them becomes the member of AST-PTMA. This is Association of Science, Technology, Engineering Faculty of Muhammadiyah Universities. So this is the contribution of Muhammadiyah 100 years after Kiai Ahmad Dahlan established organisasi Muhammadiyah, Persyarikatan Muhammadiyah. We manage 170 universities across the nation, from Aceh to Papua. More than 500,000 students enrolled in Muhammadiyah universities or higher education. This is huge contribution to the nations. And also for the SDGs itself, by doing this, actually Muhammadiyah already contribute to the SDG achievement, which is goals number 4, which is quality education. Next, please. Now, the issue of SDGs, Sustainable Development Goals. In 2015, United Nations and signatory member countries agreed to set up 17 goals. Set up to 17 goals, and between countries they collaborate, they organize activities, set up goals, parameters in manage their countries. From 17 goals, actually 7 goals, classified as the ends. Jadi dari 17 SDGs yang muaranya itu adalah well-being, muaranya adalah well-being of people, itu ada 7 goals. Number 1, no poverty. Number 2, zero hunger, good health and well-being, quality education. Kemudian gender equality, decent work, and goal number 10, reduce inequalities. Jadi dari 17 tadi oleh Siti dikategorikan 7 itu adalah terkait dengan well-being. In the end we find out that this is the hayatan thayyibah. Jadi well-being itu dalam terminologi Al-Quran itu adalah hayatan thayyibah. Falanuh niyanahu hayatan thayyibah. The end of the goal is hayatan thayyibah of human being, well-being of human being. Meanwhile, the other 10 goals is a means. Yang goals yang lain, yang 10 itu adalah cara untuk mewujudkan hayatan thayyibah yang diindikasikan dari 7 goal tadi. The other 10 goals is more a means, the way how to achieve the hayatan thayyibah, the well-being of human being tadi. So by this framework, Abdurrahman et al. In 2015 proposed framework, Islamic framework of SDGs. The core of goals is well-being, human being well-being. Jadi hayatan thayyibah. Again, because human being is the main actor in this earth, so the focus is the life of human being. How to achieve well-being, how to achieve hayatan thayyibah, kehidupan yang baik, kehidupan yang menyenangkan, kehidupan yang bahagia di dunia ini. However, this is the difference between SDGs in UNESCO UN perspective and Islamic perspective. In Islam Creed, di dalam rukun atau kredo, rukun iman, rukun Islam, agama Islam, the first obligation of human being is ibadah, beribadah kepada Allah, acknowledge the Creator and submit to the Creator. So this is one main factor of hayatan thayyibah in Islam. So that's why the indicator of well-being based on Islamic perspective, including pious faithful, jadi ketakwaan dan keimanan, iman dan amal soleh. Ini menjadi center di dalam well-being, hayatan thayyibah bagi manusia. Sementara yang lain, the others, yang di 7, ini semua adalah ajaran dalam Islam. Kalau dirunut sejarahnya, dirunut dalil-dalilnya, all these 7 and even 17 goals, there are root in Quran and Hadith. Literature can be found everywhere. Okay. So these are example of model how SDGs viewed from Islamic perspective. Al-Jayusi and then Daria. There are some Islamic terms associated with concept and approach of sustainability. Al-Jayusi proposed 6 value, which are arham, which is social capital, synonym to social capital, and then mizan, balance between spiritual and physical worth of human being, and then tasbih, prayer, relationship between human being and the Creator, adl, justice, and ihsan, the beauty. Ihsan here is the beauty, the beauty of this world life. Daria et al. Propose a model for sustainable development based on Islamic worldview. Again, the center of the model is good life, hayatan thayyibah. So, the good life of human being. Again, here we have limit of mischief, fasad, justice, adl, excellence, ihsan, and arham. The social capital, the relationship between within the family and between the family and society. This play important role of hayatan thayyibah. Next, please. So many believe that Islamic teaching is highly compatible with SDGs, except for one aspect, the spiritual aspect. So we can say that 17 goals is exactly what Islamic teaching gives us, minus the spiritual aspects. Yeah. So this is the challenge. How, as Kiai Haji Ahmad Dahlan did in early 90s, yeah, we can transform the society, Muslim society, to embrace, the sustainable development goal. Jadi tantangannya masih sama dengan yang dihadapi oleh Kiai Haji Ahmad Dahlan. Cuma kita beruntung karena kita punya contoh, kita sudah mewarisi itu. Bagaimana Muslim, masyarakat Muslim yang sebagai hasil dari ratusan tahun kolonialisme itu memiliki barrier yang sangat besar, yang sangat kokoh dengan dunia modern yang diidentikan dengan dunia barat. Dan dunia barat identik dengan sekulerisme. So this is the challenge. Tantangannya adalah bagaimana, the challenge is how we can continue what Kiai Haji Ahmad Dahlan did 100 years ago. To systematically transform the society, in our case academicians, students, to embrace the SDGs as the whole part, the integral part of Islamic teachings. However, this is also the challenge. Many experts say that yes, you can say that Islam is compatible with SDGs, but show me one single Muslim country in the world with outstanding achievement of SDGs. The answer is none. Even the Saudi Arabia, the Kingdom of Saudi Arabia, they have very large, very vast amount of oil money. Even with that abundant money, unlimited money, Saudi Arabia has no program for renewable energy. So this is very ironic. You say that Islam is very compatible with SDGs, but please give me one example. The answer is none. So the psychological and historical barrier between Islamic world and the West was blamed. Jadi lagi-lagi yang disalahkan adalah ini karena kolonialisme, hasil kolonialisme dan seterusnya. In 2012, Prince Charles, still Prince that time, now Kang Kim, and the King of Jordan, established 1001 inventions. Jadi tahun 2012, Raja Jordan dengan Pangeran Charles membuat inisiatif 1001 inventions. The goals of the incentive is to try to minimize, or to not destroy, but to minimize the barriers. So Muslim world and the West itu become closer. Jadi inisiatif ini, program ini, kampanye ini tujuannya adalah untuk mendekatkan umat Islam dengan dunia Barat. Caranya bagaimana? Caranya adalah menggali warisan-warisan teknologi, warisan ilmu dan teknologi dari abad pertengahan, the Golden Age. Sehingga Muslim world, Muslim societies dengan Barat itu sebenarnya punya nasab yang sama, yaitu adalah Muslim abad pertengahan. Sudah ada upaya bagaimana mendekatkan dunia Barat dengan dunia Muslim agar tidak selalu terjadi curigation gitu ya, tidak terlalu saling curiga, saling merasa bermusuhan. Tapi sekarang dengan kasusnya yang terjadi di Palestina menjadi ambiar lagi kan, seperti itu. So for the autocritic of Muhammadiyah Engineering Higher Education, we need reconstruction, ya. We need reconstruction, religious reconstruction to provide more robust theological foundation for engineering and technology advancement in Muslim world. So this is the example how we try to contribute, to address the challenge. In 2021, UMS Rector already signed the new strategic planning, RENSA, document RENSA. One correction is the shift of educational paradigm in response to outcome-based education. So the Islamic values, in the previous document, were constructed by using a philosophy of science framework, ontology, epistemology, and axiology. And the 7 values, tauhid, ibadah, khilafah, istisah, ilmu, adil, and amanah, filled with this framework. This framework is suitable for the input-based education because the focus of input-based education is the body of knowledge. When we talk about the body of knowledge, and the framework is philosophy of science, ontology, epistemology, and axiology. But after OBE become common, become mandatory in higher education, we need to reconstruct the Islamic value in UMS. And then we use, because the focus is graduate profile, then we use belief, value, and character to reconstruct the Islamic value of Universitas Muhammadiyah Surakarta. So the core belief is Tauhid and Akhirat, and then described by Iman, Islam, Ihsan, and Taqwa. And then the value here is what is the God purpose when He created man. There are 3 purposes of creation. The first one is Khalifah, the first one is ibadah, the second one is Khalifah, and then the third one is istiqmarah. From the old value, here we introduce istiqmarah as separated from Khalifah. Previously, istiqmarah is embedded in istikhlafah, but now we take it out and make it individual values. So based on these values, and then we try to foster students to become the main characters. This is the main characters. Each program can add more characters for the student. Sidik, amanah, tabligh, fatonah. Honesty, trustworthy, sharing, and caring. So, what is the relationship between these values and SDGs achievement? In engineering education, this is very important because by excluding istiqmarah from istikhlafah, the relevance of what we are doing in engineering higher education is much more increase. Jadi apa signifikansinya dengan penambahan istiqmarah ini? Pendidikan tinggi teknik menemukan fondasi teologi yang lebih kuat. Sebab apa? Sebab istiqmaroh itu artinya adalah Allah Subhanahu wa Ta'ala menciptakan manusia, menempatkan di planet bumi agar manusia menjadikan planet bumi ini sebagai tempat tinggal yang menyenangkan. Dan peran para insinyur, para sarjana teknik itu semuanya itu bermuara kepada pengelolaan bumi menjadi tempat yang menyenangkan tadi. Ya. Teknik sipil, ya, civil engineers create roads, bridges, ya, mechanical engineers create cars, ya, arsitek create building houses, ya, industrial engineering create factories, manufacture industries, ya, etc. Ya. So this is the three UMS Islamic value: istiqmarah, khilafah, and ibadah. Hopefully, student in engineering education find more robust theological foundations when they are spending their time, their effort, their money to pursue their degree. Next, please. 5 minutes, yeah. So these are the examples of implementation. Islam and science become mandatory subject in all Muhammadiyah universities as part of Islam and Muhammadiyah lecture series. And then promoting SDGs as the themes of ICETIA. Yeah. Last year, our topic is process and product design innovation toward responsible production and consumption. This is actually SDG course number 12. Okay. This year, in accordance with the effort of Faculty of Engineering to become the center of excellence for Batik and Bengawan Solo, the topic is synergizing Bengawan Solo conservation and environmentally friendly Batik and textile industries toward sustainable river basin, and this topic strongly related to SDG number 6 and number 14. Yeah. Another example is Islamic audit instrument for green building, yeah, initiated by architecture program in collaboration with Central Board of Muhammadiyah, and this instrument audit for green building is already implemented in Muhammadiyah institution. To close my speech, these are the concluding remarks. Yeah. Sustainable development goals are very supported by Islamic teachings, but in contrast, non-Muslim countries show outstanding achievement in SDGs. Muhammadiyah University play very crucial role in achieving SDGs by providing quality higher education, yeah, SDG number 4, and preparing the student to be aware of SDGs as part of Islamic values. Yeah. And the last point is UMS 3 Islamic value ibadah, istiqlafah, and istiqmarah can be seen as promising approach to increase SDGs achievement. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Rois, for the interesting presentation. Okay, now we move to the second keynote speaker for this first panel session. Over the next 45 minutes, we'll be listening to an associate professor from the Siti University of Hong Kong. She received her bachelor's degree in chemical and materials engineering with first-class honors from the University of Auckland, New Zealand. And she was awarded with PhD in 2008 in biochemical engineering at the School of Chemical Engineering and Analytical Science at the University of Manchester, England. She has been involved in over 20 research projects as principal investigator, which mainly focus on development of integrated biorefinery strategies, include valorization of agricultural residues, food, beverage, plastic, and textile waste. She has published more than 160 peer-reviewed journal articles, and she was recognized as the world's top 2% scientist in the field of biotechnology and environmental science by Stanford University in 2020 to 2022. And she has been involved as an active member of various national and international commissions and committees, such as the Scientific Board of the International Sustainable Chemistry Collaborative Center, Germany, and she regularly serves as an external assessor for national and international funding institutions, including National Research Foundation in Singapore and Dutch Research Council, as well as European Science Foundations. That's why, ladies and gentlemen, we are honored today to have a topic of technological advancement and development of circular waste-based biorefinery for sustainable production of chemicals, materials, and fuels that will be addressed by Associate Professor Carol C. Killin. Now, please welcome our distinguished keynote speaker, Associate Professor Carol C. Killin. Professor Carol, time is yours.
Yeah, so I hope you can hear my presentation. So it's really my deep honor to be invited for giving this presentation at the 10th International Conference on Engineering, Technology, and Industrial Applications. So I wish to take this opportunity to thank you for all kind invitation. So as you could see from the title, the topic for today's talk is focused on technological advancement and development of was received field every day in 2021. So this accounts for 30% of the total municipal solid waste. And the amount of waste generated increased every subsequent stages of the food supply chain, especially at the manufacturing and the retail consumer, what we call the post-consumption stages. Hello? Hello, is that okay? I just continue? Yeah. Is that fine if I just continue like this?
Okay,
Can you
Dr.
hear me?
Carol, excuse me, can you on the camera, please? Can you turn on the camera?
Okay. Yeah, so I will just continue. So this slide just shows a good summary of the technologies for food waste valorization. And the concept of food waste valorization has been receiving increasing attention from the researchers, industry, policymakers, because of the superior advantages over traditional management approach like landfilling or incineration. So the possibility of using negligible food waste and the integration of sustainable practices and low environmental impact technologies in waste biorefinery could offer already widely implemented and have undergone further development. But what we find is that by using this second generation valorization technology could produce material and extract specific components that are subjected to recovery and conversion processes to obtain different classes of products like refined chemicals and biofuels. So this slide shows the three major renewable resources feedstock that are used by my research team, which mainly consists of agricultural crops and residues, food waste and byproduct streams, also the textile waste and byproduct streams. So these are the three most abundant organic waste streams in Hong Kong, and it is important to use efficient biorefinery strategies for recovery of these nutrients. So in my research team, these are the main approaches applied which can pre-treat the feedstock in order to allow efficient pre-treatment and fractionation in order to recover the nutrient source from these feedstocks. In addition, industrial biotechnology and green chemistry will be applied in order to transform the nutrients from the waste stream into value-added products. So the first project, titled Conversion of Food Waste into Polylactic Acid Fiber, was funded by Hong Kong Research Institutes of Textile and Apparel and a few industrial sponsors. So the main objective of the project is the conversion of food waste into PLA fiber. And the project is divided into three stages in which my research team were responsible for the work package 1, the production of lactic acid by fermentation using food waste, and work package 2, polymerization of lactic acid into PLA. And our collaborator from the Hong Kong Polytechnic University were responsible for work package 3, the spinning and testing on rheological properties and facture morphology. So as shown in this particular slide, the main objectives for the second project, which is on the textile waste recycling by biological method, is to have a bioprocess to recover glucose and polyester from textile waste so that it could be reapplied in the textile industry. So I'm very glad to have H&M as an industrial sponsor. In collaboration with H&M, we developed advanced recycling processes to valorize waste textiles. So here it shows that a biorefinery strategy is proposed in this project. So in general, the cotton in waste textile has hydrolyzed and become glucose, which is then purified and converted into a variety of high-value bio-based products, while the remaining polyester was regenerated into fiber by melt spinning for application in the textile industry. So in our group, the recovered PET from textile waste fiber has been respun into new fibers by melt spinning as presented in this figure. And this work was conducted by Industrial Technology Research Institutes in Taiwan. So the polyester recovered from hydrolysis is respun into fully orientated yarn by granulations, molecular weight increases, and melt spinning and also drawing. So here show the resultant PET fiber, which were produced using 20% of the recycled PET chips from textiles and 80% of the chips from PET bottles. So the resultant yarn has a tenacity over 3 grams per tennant and elongation of 20 to 40%, which is suitable to be applied in the textile and apparel industry. So after the laboratory process was completed, feasibility study to scale up the process in industrial scale was conducted by my PhD student, Dr. Guangzi Him, who carried out the study at ATP Potsdam in Germany under the supervision of Dr. Joachim Venus. And after completing the Phase 1 project, my research team also participated in the Phase 2 project for designing and building a 500-liter pallet scale system for the textile waste recycling via biological method developed in Phase 1 of the project. So in this project, the pilot plant was built and it is now located at the research lab of the Hong Kong Research Institutes of Textile and Apparel at the Hong Kong Science Park. So my consultancy role in the Phase 2 project is to develop an economic model using the spreadsheets or simulation software packages. And the 2 scenarios have been conducted, which are the 500-liter scale and the commercial scale. So after mentioned in the previous slide, the latest research project that I have been involved is recently funded by the Engineering and Physical Science and Research Council in the UK, under the theme of Recycle Research of a Plastic Circular Economy. So the aim is to develop an integrated waste refining strategy for extracting plastic and cotton fiber from textile waste to be used as raw materials in the textile industry. So the ultimate ambition is to develop a textile waste refinery to recycle PET, cellulose, and dye, while producing heat and power, adjusting within this project and extending to metal and other accessory, glue, and other polymers in the future projects. And this figures illustrate the proposed textile waste refinery. So in the work package 1, we intended to use AI enhanced waste sorting to separate the textile waste to PET only, cotton only, and mixed PET cotton textile waste, as well as sorting waste based on the colors. And for work package 2 would be the physicochemical pretreatment to reduce the size of textiles, followed by ionic liquid extraction for dye recovery. So my research team mainly involved in the work package 2 and 3, which involve the extraction and enzymatic hydrolysis that will be used separately and together for the removal or partial degradation of cellulose from textile waste. And work package 4 will be the solid waste residue that will be processed in a low-flow pyrolysis unit, and the gas is combust in a micro gas turbine to generate heat for the pretreatment process and power to export to the grid. And lastly will be the overall sustainability of the proposed strategies, which will be assessed to confirm the viability of the scheme and its environmental benefits. So next would be the presentation. So next would be the presentation about the COVID-19 pandemics. Okay, since the outbreak of the COVID-19 pandemics, the personal protective equipment, PPE, were increasingly to reduce the risk of viral transmission. However, the massive increase of medical waste was observed due to the enforcement of the infectious control measures, which causes severe plastic pollution problem and pose threat to wildlife. So many countries have regulation to ban the use of single-use plastic for disposable items, and therefore biodegradable and sustainable raw materials for PPE would be the future trend. And also, we foresee that technological integrated biorefinery focused on materials recovery approach will be actually needed. So this is how we start with our CLF project that aims to develop a food waste-derived non-woven medical textiles via electrospinning techniques for PPE, and also to evaluate the environmental economic impacts benefits associated with these sustainable and bio-based textile material methodology. So in total, there are 5 tasks associated in this project, and they are closely linked with each other. So here it shows the overall tasks, 5 major tasks involved. The first task is the food waste hydrolysis, and the second task is the fermentative lactic acid and PHPB production using food waste hydrolysis. And the third task is the development of the PHPB and PLA blend non-woven medical textile via electrospinning. And the fourth would be determination of fabricated textile characteristics and virus viability in the artificial saliva droplets. And lastly is to evaluate the environmental economic costs and benefits associated with alternative pathways for the medical textile material development and production. So in task 1, we purify and study the interactions among enzyme substrate inhibitors in a well-controlled environment by using model compound, synthetic food substrate, and the real food substrate. We also develop functional additives and optimize the process control to overcome the hydrolysis inhibition issues. And in the task number 2, we have derived nutrient-rich hydrolysis that will be applied in task 2, in which we develop novel fermentative strategies and production recovery protocols for food waste hydrolysis in microbial fermentation for lactic acid and PHPB production. And in task number 2, we have been using immobilized cells bioreactors to improve the process productivity, because they can establish continuous operation with high cell densities, increase both the yield and productivities. And at the same time, we can simplify the downstream processes as the cultural growth with very low cell density would be collected. And what we have done is my postdoc, Dr. Jin Hua, he has developed this in situ fab-spec bioreactor using the sugarcane bagasse as immobilization materials. So in this in situ fab-spec bioreactor, The solar support consists of these low-cost agricultural residues, like these sugarcane bagasse materials, and these are attractive as compared to the costly constructed stainless steel metal package. So in fact, lactic acid is a promising building block with a high value production of commodity and specialty chemicals, which has diverse applications. So the global lactic acid market was evaluated with US dollars 3.1 billion in 2023, and they're expected to grow with a compound annual interest rate of 8%. So this lactic acid could be also produced by microbial fermentation with the advantage of cheap and available substrate and low energy consumption, and also the mild temperature control as compared to the synthetic. So during the organic fermentation process, the pH was controlled in order to keep an ideal range for the cell growth and efficient productions of the microorganisms. So here, by using the commercial base, such as sodium hydroxide, potassium hydroxide, these are the very common types of commercial base that are applied. However, because of the cost arise and also the high osmotic stress would be prone to the microorganisms, and also the issue with the corrosion to the equipment, then therefore what we have considered would be using a green and sustainable approach by using the seashell waste, because it contains 96% of calcium carbonate, which could be used as a neutralizing agent in the lactic acid fermentation, and this could also yield a high concentration when added to the broth. So this commercial calcium carbonate would actually would be a green and sustainable replacement for the commercial based. And here it just quickly shows some of these fermentation results using the seashell pieces as a neutralizer in the shake flask. And here we could see that by investigating using a synthetic medium with initial glucose concentration from 20 to 100 grams per liter, we could see our strain, the lactobacillus strain, can actually produce very high amount of lactic acid concentration, up to 88 grams per liter, with a high production yield and productivity of lactic acid, up to 1.44 grams per liter per hour. And after this initial preliminary study, what we have done is we also used 2-liter bioreactor and also various size of seashell waste powder and fine powder in order to see the neutralization effect on the fermentation. So the further investigation of this seashell waste in lactic acid production were examined in these 2.2-liter bioreactors. And firstly, the lactic acid fermentation using the food waste hydrolysate was conducted automatically at a pH 6 by using 10 molar sodium hydroxide. And afterwards, we could see that we subsequently replaced with the seashell pieces, seashell powder, and seashell fine powder. And the result shows that the optimum form of the seashell waste would be the seashell fine powder, in which we can achieve around 83 grams per liter of lactic acid with a high lactic acid yield and the highest productivity of 1.53 grams per liter per hour. So essentially, by applying the seashell waste, you could save up to around 40 grams per liter sodium hydroxide usage per liter of fermentation broth under this experimental condition. And later, what we have done is we've been using in situ feedback bioreactors to increase the productivity by using this seashell fine powder as compared to the sodium hydroxide. And the result shows that we achieve a very high productivities of 1.9 grams per liter per hour and a very high glucose consumption rate up to 3.41 grams per liter per hour by using the seashell fine powder. And the overall result basically demonstrated that these seashell fine powders were proved to be a superior neutralization agents as compared to the sodium hydroxide. And the highest glucose consumption rate productivity were demonstrated, and we can basically save around 250 grams of sodium hydroxide per liter of fermentation broth. So now we move on to task number 3 of the CLF project. In this task, we like to select the suitable ratio of PHPV and PLA blend for electrospinning to produce sustainable textile and fabricate non-woven textile materials with targeted pore size at the same time to maintain a hydrophobic surfaces. So the fabricated textile were examined in task number 4 to achieve the desired properties with at least 50% reduction in the deposition rate on the hydrophobic surfaces and at least 95% of droplet filtration with acceptable breathability. And for the task number 3, what we have done is, in order to know the degradation rate of the medical textile we produce, we especially focus on the biodegradability, because we know that most of these plastic waste, they are either decomposed in landfills, and at the same time, some of these will be decomposed in the natural environment, like the soil or aquatic environment. So therefore, degradation of bioplastic and the plants into the environment were conducted, and some of these preliminary results were discussed here. So the campus degradation was conducted according to the ISO standard, and here are the degradation curve and the sample photos of control group cellulose and PP nanofibers of the pure PLA and PLA PHPV blend of different ratios. So both PLA and PHPV are composed degradables, and their blends also shows good degradability of complete degradations within 4 weeks. And this is particularly fast degradation speed because most of these nanofiber textiles would have a larger surface area, and therefore it would degrade faster than the synthetic PP. And however, if you try to conduct the marine degradation experiment by putting this electrospin sample under the marine environment, we have observed that there were no degradation for pure PLA. However, there would be a possibility of improved the biodegradability by increasing the PHPV content of the blend according to the ratios of 7:3 and 5:5. And here it shows the SCM photos showing the before marine degradations and after the marine biodegradations. And we could see these nanofibers, which are basically melted together and after the biodegradation. And at the same time, we further analyzed the residual samples of the blend 73 after marine degradations, and the NMR and TJ result also suggests that only PLA were retained after these marine degradations. So for the future work, what we intended to do is to test the impact of different blending ratios on the degradations and investigate the mechanism of biodegradation process of the plants and identify the degradation bacterium at the enzyme. So the future research will investigate the effects of degradation of plants on surrounding environment, like the soil properties and the soil microbial diversities. So towards the end of the study, the life cycle assessment quantified the environmental impacts of the bioplastic degradation to provide a clear understanding and also to compare with the conventional plastics. So the next project will be on the biosurfactants, which is a recently funded EU RGC project, which is led by the Ghent University in Belgium. And the slide shows the background of the EU Horizon 2020 research and development projects titled lactic acid and biosurfactants sourced from sustainable agricultural and industrial food waste feedstock as novel functional ingredients for consumer products. So this project started in June 2021, which is coordinated by the Bio-Based Europe Pilot Plant, by the Department of Biotechnology, Faculty of Bioscience and Engineering at the Ghent University in Belgium, with various academic and industrial partners. So these surfactants have been widely used in industry of petroleum, adhesive, flocculating, wetting, and foaming agents, and also penetrants because of the properties of lower surface tension, increasing solubility, the detergency power, wettability, and foaming capacities. So the global-based biosurfactant market is expected to reach US $6.4 billion by 2025, with the annual growth rate of 5.5%. So Sababella bubuncular was actually isolated from the Nictus bumblebees and has been widely studied strain to produce cephalipids because it can produce high titers and productivity of cephalipids. And this figure shows a typical cephalipids production process in the lab scale. And these cephalipids can produce predominantly this, what we call the electronic cephalipids as the major form, and the manufactions as the free acid form. So this slide showcases some of the previous cephalipids research conducted by my research team. So what we have done is to do the screening of multiple organic waste streams as the nutrient source for the cephalopods via batch and fed batch fermentations. We also conduct the optimization in the semi-continuous fed batch fermentations, and also techno-economic and life cycle assessment for the cephalopods production and waste streams. And finally, the bakery-based oil-based cephalopods production and optimization. So our EU RGC project, which is titled Development of One-Step Food Waste Biorefinery via Novel Bioreactor Designed Functional String Adaptive Laboratory Evolution and Genetic Engineering, consists of these 4 work packages. So the proposed project is aimed to develop a food waste-derived biosurfactant via a very novel bioreactor design and genetic engineering of robust yeast to explore the bioeconomic viability of the waste biorefinery. So in summary, all these developments would actually lead to the production of a modified cephalopods to actually secrete the hydrolytic enzyme and to tolerate the food waste inhibitor in improved cephalopods productivity by using this one-pot bioreactor design. And we hope that by tailor-made this one-pot bioreactor, we can conduct the food waste hydrolysis and fermentation together, and therefore to reduce the cephalopods production cost that would benefit to the market, and also at the same time leading to a carbon neutral biorefinery and positively affect the society. So in fact, several of my research team members have recently established a startup company via the Hong Kong Tech 300, which is a large flagship innovation entrepreneurship program organized by CityU for aspiring entrepreneurships among CityU students, alumni, research staff, and others to launch a startup and ignite the entrepreneurship journey. So the program aims to create 300 startups in 3 years, providing educational and growth opportunity for CityU students, translating CityU research results and intellectual properties into practical applications. So one of these companies is Research, which is an ecological startup incubated at the City University by a team of chemical engineers and sustainability scientists with the seed fund support from CityU and also from the Hong Kong Science Park. And the goal is to accelerate the circular transition from a bioeconomy point of view by bringing this biosurfactant to the market with an affordable price, while at the same time by solving the key sustainability challenges in the biosurfactant, as well as the biosurfactant-derived green production trend. So the 2 last topics which I'm going to cover is the bio-based polyurethane foam, which is a recently funded project by the City University of Hong Kong. So the project was initiated by Dr. Marcus Kupers from the Polymer Laboratory at the Lafayette State Institute of Wood Chemistry. So the objective of these projects include to investigate the use of food waste lipids, food waste lipid-based polyols, and the respective the rigid polyurethane foams. And secondly is to model the process flow based on the laboratory scale experimental work and to build the materials balance of the overall process in an industrial scale. And the last is to perform the techno-economic assessment and life cycle assessment to understand the economic competitiveness and environmental performance. So here just basically shows some of the experimental work. So after we obtained the food waste-derived lipids, we sent it to the collaborator in Lafayette. So they have conducted epoxidation and also the ring opening polymerization in order to obtain the hard PU form. And we try to compare the thermal conductivities and the characteristic with this food waste-derived lipid PU as compared to the other PU form that are conventionally used in the construction industry. And the result shows that the characteristics in terms of density and thermal conductivity were very much similar to the conventional insulation material applied in the construction industry. And next, we are currently conducting the process design using SuperPro Designer, and we assume that we are going to construct a 10 metric tons per hour food waste treatment plant in the location of Greater Bay Area in mainland China. And we assume that this plant is going to operate for 20 years, with the first year for construction and startup phase. And at the moment, we are conducting the mass material balance and also try to estimate the revenue, availability, and sensitivity analysis. So this basically shows the slide showing the overall process design of the process. So the first part of the main process is the food waste hydrolysis and separation. And here we intended to use some of this green solvent for the extraction of the lipids for the second process, which involved the bio-based polyo and polyurethane foam synthesis. And also, the food waste hydrolysis itself will be used as a side stream for the production of the PHBV, which we could be used in the CRF project. And the result shows some of the preliminary economic analysis. And here it shows that the highest equipment cost will be the stirred bioreactor, which will be used for the hydrolysis of the food waste. And the revenue will be mainly contributed by selling the PU formed, and also the protein could be recovered for the animal feed. And in terms of the materials cost, we could see that the use of isocyanide for PU formation would occupy the highest material cost. So in terms of future work, we are continuing with techno-economic analysis, and what we have assumed that after continuing the different scenario comparison by using different plant capacity, using green solvents, and also maybe producing polyo as one of these intermediate products, we also will conduct the life cycle assessment and see to compare the energy use and also some of the greenhouse gas emissions from these processes. So the very last topic that I'm going to cover is the microalgae cultivation for permafrost production using food waste hydrolysis. And this work is in collaboration with Dr. Wang Sang from the Jiangnan University. So the reason why we are very much interested in this microalgae platform is because we know that it could be used to produce a variety of high value-added products. So in this study, the production of permafrost, which is a polysaccharide, from these microalgae E glaciers was conducted using the waste-based immobilization cultivation. So this permafrost, this polysaccharide, could be produced by the microalgae, and it has a very wide range of medical and food additive applications. And the study also shows that it could be cultivated using large-scale cultivation method like the outdoor cultivation or the photobioreactor cultivation. So that's why we aim to investigate the potential use of food waste hydrolysis for e-glacier cultivation and examine the performance of sand immobilization cultivation using food waste hydrolysis for enhancing the permafrost production. So this e-glacier was cultivated in an artificial climate chamber in 1 liter Duran bottle containing 600 milliliter of sterilized filtered synthetic medium with an initial glucose concentration of 20 grams per liter. So this mixotrophic cultivation was cultivated at 25 degrees Celsius in the 12 hours light and dark cycle. And at the same time, we also compare the cultivation in the heterotrophic cultivation mode, which does not contain any light illumination. That means we do the cultivation in the dark fermentation condition. So here just quickly show some of the preliminary study by using the immobilization materials such as sugarcane bagasse or the waste sponge on the e-glacier cultivation. So during the mixotrophic cultivation, what we have observed that the e-glacier exhibit ability to do the immobilization, and from these different repeating cycles, it can actually produce a good amount of the permafrost. However, we find that after the first 2 cycles, the production of the permafrost dramatically decreased, and it was cultivated using sugarcane bagasse. So I think and also at the same time, we find that when we do the cultivation in the heterotrophic cultivation, in the dark fermentation, that would lead to the production of carotenoid because the color of the broth actually turn yellowed and white, milky white, which imply for the synthesis of carotenoid. And if you look at the SCM photo here, it shows that the undesired immobilization by using sugarcane bagasse, and it shows that there are some cell debris and lower surface occupation as compared to the cultivation using the waste sponge, which does not lead to any cell lysis. So in summary, we like to conclude that in this study, the microalgae permafrost productivity up to 2.22 gram per liter per day we achieved under the heterotrophic, the dark fermentation cultivation. And the conclusion shows that by using the waste sponge, there will be a more suitable supporting material for the paramalon production. And lastly, we basically have successfully demonstrated we can combine the waste-based immobilization as well as the food waste-based cultivation medium for realizing the green and sustainable processes of the microalgae cultivation. So before the end of this presentation, I'd just like to take this opportunity to thank you all the funding bodies, industrial sponsors, and project collaborators, as well as project team members for making this work possible. And finally, thank you very much for your kind attention, and I look forward to your questions.
Thank you, Professor Caroline. Okay, now we'll move to discussion session, and we have 30 minutes for discussion or question and answer. And for the offline audience, if you have a question, please raise your hand, mention your name and institution, and then state which speakers you address the question for. Okay, and for the first discussion session, I will invite 3 participants to address the questions to its speakers. Okay, Pak Komarun and then Pak Solikin. Okay, please Pak Komarun.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Introduce myself. My name is Komarun. I'm come from Muhammadiyah University in Surakarta. I have 2 questions for Prof. Caroline. It is interesting with your presentation about how to recycling it. From textile waste, in biological, can I say? Biological method. I have 2 questions. As a human being, I don't understand so much because some come from other engineers. The first question is, what kind of biota? It is a flora or fauna, virus, bacteria, or something else? And the second question is, how about the industry? It is a small industry, can be used by a local method or a large industry. In Solo, we know batik, textile of Indonesia. There's a lot of small enterprise. Thank you, Pupur.
Check. Okay, thank you, Ms. Purwanti, for your time. Okay, I would like ask question to Prof. Carol C. Prof. Carol, you mentioned that you extract the waste from textile waste industry, from food industry. My question is about how much you can extract the important substance that you need for the next process, like a PET and the other one. How much you can extract actually? And then is it possible to improve the extraction? Okay, that's my question. Thank you.
Professor Caroline, are you clear with the first question from Dr. Komarun? Hello? Excuse me. Still mute.
Hello, hello. Can you hear me?
Hello. Are you clear with the first question from Dr. Komarun about the what kind of biota of flora and fauna that can be recycled, that can be used?
So the first question is related to the substrate that could be recycled apart from food waste. You mind to type the question in the chat so I can clarify the question.
Okay, Pak Komarun, can you repeat the question, please?
Well, I need to know about the biological methods, because it needs biological methods. So there's a lot of biota that used to recycling process. So what kind of biota it is used, or flora or fauna or some.
Okay, so the question from Dr. Komarun is about what kind of biota or flora or fauna that can be used in the process of the recycle. That's the first question, Professor Carol.
Yeah, I think in terms of the substrate, I already that my research really focused on the use of food waste, agricultural waste, and textile waste. Yeah, so these are the main waste streams that we've been using in various different projects. Yeah. So, and in terms of organisms, we've been using different microorganisms, for example, bacterium, yeast, microalgae. So these are the conventional microorganisms that we used for the as the second valorization technology to upcycle the nutrients into other value-added products. Yeah. So I hope this answers your questions.
Oh yeah, so Alka, yeah. And the second question is about the industry textile. It can be used in small enterprise industry or large industry company.
Okay, so the second question is that applicable for small industry or for large industry?
Yeah, this is also a very good question. In fact, most of these projects were initiated by large-scale industry, like the H&M, and also I have not mentioned there were some previous projects initiated by the PepsiCo, the food and beverage industry, and also the lawful side. So these are the large-scale industry that which would like to initiate this project and see whether the outcome could be applied in the real industry itself. But of course, some of the projects, like the PLA project that we first started in 2016, so that project was actually initiated by different companies in Hong Kong and also mainland China. And those are smaller industry or companies that like to initiate for the production of food waste into lactic acid. So I think the technology that are presented in this particular talk, they are relevant to both small and large-scale industries. So I hope this answers your question.
Okay, thank you. And then the next question from Dr. Solikin about the extraction from the waste. So the first question, I think, how much you can extract the important substance from the waste?
So this is a very good question also. So if you're talking about just extracting the glucose from the food waste, after hydrolysis, we usually just produce up to around 100 grams per liter glucose, because most of the organisms, if they like to utilize the glucose stream, there will be significant inhibition if the initial glucose concentration is over 100 gram per liter. As for some of the project, in fact, we can get up to 200 gram per liter or even up to 500 gram per liter. So it very much depends on the types of projects that, and also the end products we are trying to recover or try to produce. But I would say if we are using glucose as the initial parameters, then I think around 100 gram per liter would be a optimal initial glucose concentration that we like to achieve. And the same for the nitrogen source. If we are talking about the free amino nitrogen, usually for most of this fermentation, the bacterial fermentation, they need around 200 to 400 milligram per liter. But some of the fermentation process, if you have very high initial free amino nitrogen concentration, it can actually inhibit the cell growth at the stationary and also at the exponential growth phase. So this again depends on what kind of microorganisms and what are the products that we are trying to produce using these different types of fermentation processes. So I hope this answers your question.
Enough, Pak Solikin. Okay. Thank you, Professor Carol. And there is a question from Pak Solikin to Professor Rois. So after the brilliant concept of compatibility between SDGs and Islamic teaching, how to start the application of the concept?
Yeah, thank you very much, Pak Solikin, for the questions. This is very simple question, but very difficult to answer, yeah, because everyone understand that to start we need initiation energy, huge initiation energy. But otherwise, we will not know, ya. Kita tidak akan pernah tahu hasilnya kalau tidak dimulai, ya. There are example from other universities, ya, how to incorporate SDGs in their curriculum. So, some of the experience they share by publishing in journal, reference journal, conference articles. They start with the mapping of curriculum, the mapping of learning outcomes. Yeah, so they address 17 SDGs and which courses already address the its goals for 17 SDGs. The ultimate goal is again to increase the awareness of the students about the SDGs. So basically, currently we don't address the SDGs because this is the contemporary issues, yeah. And before the SDGs, we have MDGs, yeah, Millennium Development Goals, and then now Sustainable Development Goals. And the timeline is only to 2030. After that, we don't know. SDGs round 2 or SDGs reborn or zenith, entah bagaimana. Jadi untuk memulai ada sudah beberapa contoh, beberapa universitas mereka memulai dengan mapping, ya, kurikulum mapping, CPL mapping, mana yang sudah mengadres each dari 17 SDGs tadi. Nah, kemudian dari mapping itu nanti kemudian secara sistematis beberapa SDGs yang belum diadres itu dibebankan kepada mata kuliah tertentu, begitu. Itu dari sisi kurikulum. Kemudian dari sisi Center of Study, ya, jadi insya Allah ini Pak Rama tadi ada nggak? Pak Rama mana Pak Rama? Ya, hilang, ya. Pak Rama ini kemarin ke Malaysia itu sudah Pak Rama went to Malaysia probably almost 1 month, ya. He spent time in Malaysia from university to other university, his focus is on SDGs. So inshallah there will be SDGs center in UMS, ya, motored by Pak Rama. Again, the objective of this center is to increase the awareness of the SDGs, 17 goals, both to student and instructor, lecturer. Yeah. And then the other way, the what I presented in my speech, we need religious reconstruction. So we try with ibadah istikhlafah and istiqmarah. By excluding istiqmarah from istikhlafah, hopefully the students, the lecturers in engineering faculty of Muhammadiyah Universitas become more yakin, gitu ya. Jadi mudah-mudahan dengan mengeluarkan nilai istikhlafah dari nilai istiqmarah dari istikhlafah ini memberikan keyakinan yang lebih kuat kepada para dosen, pada para mahasiswa bahwa mengajar, belajar itu bukan semata-mata mencari rezeki untuk yang mana nanti rezekinya digunakan untuk beribadah, tetapi bahwa apa yang kita lakukan, ya, mewariskan pengetahuan teknologi, mengembangkan pengetahuan teknologi untuk kesejahteraan manusia di bumi, ini adalah mandatori, ya. Waladzi ansya'akum minal ardi wastamarakum fiha. Jadi ada landasan yang sangat kokoh bahwa Allah Subhanahu wa taala telah menciptakan kita dari bumi dan menjadikan kita pemakmurnya. Dan proses pemakmuran bumi menjadikan bumi ini tempat tinggal yang nyaman sehingga tidak bunuh diri, tidak putus asa, ya. Ini adalah mandatori dari Allah Subhanahu wa taala. Gitu ya. Jadi tidak muter kuliah, ngajar, dapat duitnya untuk ibadah, tidak. Tetapi apa yang kita lakukan ini adalah bagian dari istiqmarah, dan istiqmarah ini adalah mandatory. The purpose of creation, tujuan penciptaan itu ada 3, gitu ya. Jadi bukan hanya satu ibadah, bukan hanya 2 ibadah dan khalifah, tetapi 3, ibadah, khalifah, dan istiqmarah. Ibadah itu terkait dengan hubungan kita dengan Tuhan. Ya, wa ma khalaqtul jinna wa insa illa liya'budun ma uridu minhum min rizqin wa ma uridu imun. Jadi wa ma illa, tidaklah melainkan, itu penjelasannya adalah bahwa hubungan manusia dengan Tuhan itu semata-mata ibadah, bukan ngasih sesajen, bukan ngasih makan Tuhan, bukan ngasih rezeki Tuhan, tapi cukup mendekat, mentaati, menjalankan perintahnya, menjauhi larangannya, gitu. Dan ada mandat yang lain, ada tugasnya, yakni istikhlafah itu adalah kita mempersiapkan generasi selanjutnya. Kita ini khalifah itu adalah pengganti yang akan digantikan. Dan yang terakhir adalah istiqmarah, bagaimana kita ini mengelola bumi, menjadikan bumi ini tempat tinggal yang nyaman bagi diri kita, orang-orang zaman kita, dan generation to come, ya. Sebab sudah disabdakan oleh Allah, manusia itu akan tetap eksis di bumi sampai hari kiamat, gitu ya. Jadi sustainability of human being-nya itu harus kita wujudkan, karena Allah sudah menyatakan seperti itu. Begitu Pak Solihin, kurang lebih. Terima kasih.
Okay, is there any questions from the participant? Because there is no more question from the online participant. We still have 10 minutes for this discussion session. Any more questions? Okay, if there is no question from the participant, I would like to ask a question to Professor Carol. Dear Professor Carol, can I ask you questions?
Yeah, please. Thank you.
Okay, you stated that the biodegradable plastic in the future will be a trend. And I read from some media that in Indonesia there has been a production of biodegradable plastic that made of cassava starch or tapioca, and also made of a seaweed, I think. And could you please give an insight about how to overcome the trade-off between the demand of food and the demand for biodegradable material in the future? Thank you.
Yeah, thank you for your nice questions. So, yeah, in fact, I think the ideas that you mentioned, using seaweed or other food-related materials for biodegradable materials is a trend. And for us, I think we are more focused on the bio-based plastic, like PRA, PHPV, or this bioplastic, is because the method that we applied in the CRF project will be involving the use of this bioplastic in electrospinning and also electrospraying. Because the idea is to produce a super hydrophobic surface so that the coronavirus or other any infectious virus droplets, they can deposit and they could be bounced from these super hydrophobic surfaces. So for us, the purpose is really to protect the medical workers from getting the infection from these infectious diseases. So it's quite important for us to synthesize a super hydrophobic surface in order to allow the droplets to be bounced back from the surface of the textile. So if we are using other food waste, derived or related materials as the for biodegradation applications, I'm not very sure whether the surface itself can easily made with these super hydrophobic properties. So that's why for us, for the CRF project, we very much just like to test the two common types of plastic, the PRA and HPV. But certainly what you mentioned, the use of food-based related materials for biodegradation application will certainly be the trend in the future. Yeah, thank you.
Okay, thank you, Professor Carol. Any questions? Okay, if there is no more question, then thank you again for Professor Isfatoni and Professor Caroline for answering these questions and for the great presentation as well. And it was a pleasure to have you with us. Okay, I apologize if there are some inconvenience during this panel session, but I hope that you have learned and enjoyed this panel session today, and enjoy the rest of ICETIA 2023 conference. Thanks a lot for your kind attention and participation, and I will give the stage to the MC. Thank you.
Okay, thank you for the first conference panels. That's very insightful and fruitful. And before that, I will read and I will tell you about the curriculum vitae of Mrs. Purwanti Sri Pudiastuti. She was graduated from Master of Science in Water and Environmental Management in Loughborough University, England, and also graduated from Gajah Mada University, Bachelor of Engineering in Civil Engineering. And also there was several publications such as book called Rekayasa Irigasi dan Bangunan Air, and also there are several journals such as Small Scale Integrated Sustainability, Roof Design Case Study in Surakarta City. And also, Mrs. Purwanti experienced in learning and teaching about hydrology engineering, hydraulic, water resource management. So once again, thank you for Mrs. Purwanti Sri Pudiastuti and also our keynote speaker, Dr. Rois Fatoni, PhD, and also Carol C. Kilin.
Ladies and gentlemen, we have now completed the first panel session. So it's time to take a 15 minutes break for a coffee. This is an excellent opportunity for networking and informal discussion. Please enjoy the refreshment, and after the 15 minutes, you can go to the designated room for the first parallel session. Thank you.